let's start again. So let's start just somewhere uh, in all the functions that are being called, and one of the functions that appear to me to be quite impactful is the on impact that happens before the projectile splits. Let's get rid of the profiler.
Is there an on impact before the projectile splits? Isn't the projectile splitting in midair?
Yes, but it impacts at a certain height above the terrain. So what happens is there is an detonate below height free.
Okay,
So
I see it now. Yeah. So as soon as it gets to 3 over the terrain,
then it
it
poof.
it generates an on impact.
Yeah,
Wow.
yeah.
Okay.
The for projectiles, checking the collision with the terrain is just a point query in that
Yep.
sense. So that's pretty easy. But that's what's happening here. So it has a height of 3 above the terrain, and then it runs
Does
all
all
of this
this.
code. And in this code, we create a bunch of child projectiles. So let's first toy with the code. Now, we're gonna be making changes in this code. So I took the liberty to add a p call in front of it, so that if we make a change that turns out to be not safe, right? So we change something that causes a crash, then the projectile is still destroyed. Because if we don't have this, right? So if we don't have this, but we make a typo here, then the next one, oh, there we go. Oh, it's actually falling back now. Hold on. Don't fall back. Come on.
Did you
Then
test this?
no. But typically when I make a oh wait, I know how to do this. We can just say nil. Right, so say we made a mistake. The next one will have a nil in there. There we go. And now what happens is that the on impact happens again and again and again and again because it expects the Lua code to actually destroy it at some point. And that's not happening right now. So what we're doing is we cache this function, and if it doesn't work out, then we make sure it's destroyed anyway. Because otherwise we get this, and then we need to restart, and uh, that's not very pretty. So let's restart. All right, yeah. So first things first. Let's look at the projectile class. If we go to the onCreate, then we can see here that we cache the blueprint in the projectile itself. So we don't have to do this engine call right here. We can just say self.blueprint.physics. Another easy fix that we can see right here, we're creating a local for this frag effect, but we can also just say this, where and then just retrieve that value instead of storing that in local. Another, let's switch up the comments actually so that the syntax sets up. There we go. We've got more here. We've got this engine call right here with a get army every time we create an emitter. I don't know how many there are in this one. Just one, so we only do that call once. Well, we could just get
Are you
rid of
are
this.
you not storing the army as part of the projectile?
Yeah, we are. We should totally do this. Army, and we can do that again because if we go to the projectile class, then you can see that the army here is stored. And here we don't want V. We know that this only has one entry, So we can just do this. Then, as we saw last time, this is now a global call, right? So if we search for this, then we will find it here in the sim and engine call right here, create emitter entity. We can simplify this, the scope of it by making it an up value. So
You forgot the Y. You forgot the Y. You have create emitter at entit.
create there you go. Meanwhile, let's make sure that we have at least one Zooty firing so that we get some information about. There we go. That's the type of information we like. 24 unexpected symbol. Right, so here we have it firing. So that still works. So we upvalue this one. We get the velocity here. Let's look at the documentation. It returns an XYZ. Seems fair enough. We create a child projectile. I think this is just like a comment from before. Here we have the number of projectiles. We've got an angle 2 times pi over the number of projectiles. Okay. That probably computes the... No, not fast enough. Alright, this angle change that we have right here. So we're going to need that. Num projectiles is used down here too. For some reason we start at 0. Okay, it's used right there. So this is useful to keep around. We've got an angle. We've got math.pi. This is an interesting one. So we do a global call to get the math table. And then we do a get table on the math table to get pi. And pi is roughly 3.14. So we could change this into 6.28. And then we can even go further. What is the inverse of 6.28? There you go. And then we can remove the divide. No, 1 over 6, 1 over 2 times pi is this number right here. Then we have this angle initial that's used in here. All right. But that uses random float, and random float is from utilities, and there's a lot of things from utilities that tends to do a lot of work. So let's look at this. We just want a number between the min and the max, and it uses random. So instead of using random float here, we can just say random, which returns a number between 0 and 1. And then we just multiply that with the angle. So now it returns a number between 0 and whatever this angle value is. Randomization of the spread. Adjust angle spread. Adjust the width of the dispersal. Okay. Let's just keep this together. And there we go. Then we have some information here. 0, 0. Okay. So here we create the projectiles. Again, we've got math.sinus. We can improve this by just looking at local mathsim. It's math.sim. And local math.cos. It's math.cos. Right, so this code is run once when the class is created. And these are part of the closure of the function that we have here, this onImpact function, which is why this works out. So we've got these mass since. We've got again a random float between this minus angle variation and angle variation. We create the child projectile, we set its velocity twice, and then we pass the damage data. And the damage data contains the actual amount of damage that it should do. And then we destroy the projectile that did the split. Okay, so let's look at what we have here. So this is entirely the same, with the exception that we have two random values here that are different. And we've got the math sin and the math cosinus. So let's just capture that in. We have this bit that's the same. So let's just call that A. And now we can replace this with these two. We've got this random float again. What we can do here is, so this creates a value. Let's just look at it quickly. Say angle variation is 2, then this creates a value in the range -2 to 2. So what we could do also, instead of this, is random minus angle variation, 2 times angle variation times this. This is the same thing, but now we have skipped the function call that we're doing here. So the first bit creates a range from 0 to 4, right? That's this bit here, assuming that angle variation is still 2. That's what this first bit here does. This returns a range from 0 to 1. And then we subtract 2 again from it, right? Because we want somewhere in this range. So if we would subtract 2 from this range, then we have -2, 2. And that's the range we're interested in. So we can just take this and get these out. Math sinus, math cosinus, 2 times random times spread multiplier, 0.15. Okay. That looks pretty decent. We've got this great child projectile. What is that? That is from projectile. So here we have a local projectile g dot moho dot projectile underscore methods dot now. So we can turn this into an up value, just like that. Then we set its velocity twice, which I think is projectile set velocity is moho dot projectile methods dot. Now we set the velocity here twice. And what that does is initially the velocity is not normalized. So we have a pretty large number right here, right? Because that's our current velocity that points downwards. And then we introduce some x and z direction to twist that around a bit. And here we set the velocity, but now we don't know what the, now we give it a direction, but we want to change the magnitude, right? So the magnitude, essentially what we're doing in this second step here is, if we would have the direction, then typically, right, this is the velocity direction that we have. That's what we're setting with this first call. But this has a magnitude, and the magnitude is the length of that direction. So that's this and this. And we normalize that first to a length of 1. This is not visible. That is already used. So we normalize that first with this as a length of 1. That's what this call does. And then we multiply it with the actual velocity that we would like it to have, which is 18. So now we increase the magnitude again, but then we are guaranteed that this is 18. Right? The speed of our projectile is 18 in the direction that we computed. So that's what's happening here.
So it's overriding the original velocity, which may be completely different.
Well, it's the same direction, but just
the directions
yeah,
directionality fine,
yeah.
but you can see it if you watch the projectile. It really accelerates once it splits.
Yeah, yeah. If we remove that, so this one uses the new logic, assuming it doesn't crash. Right? You see that? It becomes this. You see that? Completely different. It's almost like it's crying now. It's. We could do this. We could just remove this threat multiplier. Let's see. Yeah, that's the old one. Here's the new one. All right, so now it has roughly the same. Right, but that's.
I was just noting it where it's coming from. I didn't realize set velocity was multimodal like that.
Yeah. I actually like this. I think this is pretty cool. Okay, doesn't matter. But that's what's happening here, and I'm just yeah. No, you're right. So we need both these calls, right? Otherwise, the behavior is no longer the same. I do like this one though. The old one again. Okay. I guess it makes it too easy to evade if you don't do this.
Oh God, please.
But there's a couple of things that we can do. First of all, we're making a local for this velocity that we then retrieve, but we could just put 18 in here. Yep. Get rid of that guy. The same thing with the spread multiplier. We're doing that here, but we could just say right here. This seems to be all fine. We can upvalue the random call. Right? That's typically everything that's not defined in this file is a global. This one's not defined. Do we use the vision marker? No. We don't use the get random float either. We can remove this one here too by just saying that. And then I think we're getting there slowly. We've got this blueprint thing that's purely used for this, I think. Oh no. A fragment ID. Okay. But let's bring this one a bit closer. Let's look at this again. So we've got Vx, Vy, and Vz. And the only place where we actually use these are here, right? These values right here. So what we could say is x velocity, y velocity, and z velocity, right? These values. We remove these. Oh wait, no, we can't do that, right?
No, because you're yvec.
Yeah. We're reusing it here constantly.
Yeah, you're reusing it. Yeah.
Yeah. Okay, we can't do that. So here was a good idea that we found beforehand. So retrieve recurrent velocity. Get velocity is similar to this one. So we can do that. Delete. We've got a random call here, a random call there, another random call. All right, we're getting there in terms of what we can do at this point. we can let's clean up the file slightly. Right. So this is pretty much it what we can do at the point where the projectile splits. Now, there's this pass damage data function. That is pretty interesting too. So what that function does, if we look at projectile, is all of this, which is a bit much, right? Because technically we didn't change the damage data that we have, but we're copying it 5 times over for each projectile into the new projectile. So we could just say dot damage data is self damage data. And that would prevent us from populating that table. Now that said, we already populate that table partially with nils, which makes no sense, because if you insert a nil into the table, then the bytecode operation is performed, but it doesn't do anything to the table. So we could just say this. Right, because we're populating it here anyway when the data is passed along. Does it still work? Yes. So that shortens this table when we create a projectile. And it shortens, we skip this entirely for all these sub-projectiles. So just copy the damage data, create the projectile, and set the velocity direction magnitude, and compute a random offset for this. A random offset of the velocity for this fragment. And I think then we're pretty much it. We've got this little call that we can cache local entity destroy is g.moho.entity methods.destroy. There we go. I think we could argue that we have 3 random calls. So maybe it is worth doing this. But I'm not too sure about that. Localize for performance. We need to see if we can find a measurable difference there. But now we have the same behavior. It doesn't crash. So let's spawn 400 of these and see what we have. Right, it doesn't crash, so we don't need all of this. Does it still not crash? Let's see. All right, still doesn't crash. So this is then pretty much it, I think. Am I missing anything, Sprouto? I don't think I am.
I don't see any problem. It's still running. Let's give it a shot. I'm eager to see how much impact you get here.
Zuti 400 and WLD run with the wind. WLD run with the wind. There we go. All right. WLD run with the wind. Oh, we've got some of them moving. All right, so let's see what we have. We've got 8, 9. We never had 8 or 9 in our previous runs, right? It was primarily 10. Oh, there's 11 though. Are there still... moving around? No. Right, because pathing skews the sim, so let's make sure that they're not moving. There we go. So let's see what we have. 8, 9, 8 again, 10, 11, 12. 10.
Definitely there's some downward movement. I think
There's,
there's
yeah,
some impact for sure. I mean,
there's some
again,
impact for sure.
yeah, this is such a marginal. I mean, you
Well,
have to create a lot of projectiles to get these kind of numbers. So
yeah,
there's going to be some overhead and variance in there for sure.
I'm wondering if my CPU, it's not entirely stable. I'm wondering if that's causing an issue right now.
I don't think even if you got your CPU stable that you are going to get a stable number. There's a lot of other overhead
Yeah,
involved that's going to make it fluctuate. But you know, the fact that you're
reaching
generally,
8.
yeah, you're getting down to 8 where you weren't getting down to 8 before indicates that you've done something positive.
All right. So,
Sometimes that's sometimes the only gain you can notice. I
yeah,
mean, you do all this work and you go, oh, I've just, you know, I've really made a big impact here. But again, we're not seeing it unless we've got 400 of these projectiles all splitting at the same
yeah,
time. And it's a really tiny single improvement, but it, you know, again, going back to what you said last week, all those little drops add up.
yeah. All right. But at least what we have 8, 9, 10, but previously we always stick to 11, right? We set the baseline, if I'm not mistaken. We set that to 10, 11.
Yep.
So this is
Can
already
you
an improvement.
can you turn on the show stats panel and show the entities and the projectile numbers that are currently in play? Yeah,
Prop unit
yeah,
projectile.
yeah. You can see if you stop them from firing, you'll see the. There you go. So you
0.
can see that there's a wide variance in the number of projectiles being accounted for by the engine.
Yeah. We had 3 to 4 milliseconds. It's 4 or 5 right now.
Mm-hmm.
All right. But it's some first minor improvements, but we've got still a lot to go. So let's do that.
So
And we've
that was just the on impact function occurring in the occurring as the projectile flies through the air.
yeah, this one right here,
Still haven't dealt with the on impact that occurs when it reaches the ground.
which is this one right here.
Yeah.
All right. So let's look at this one. This is all good. I'm just gonna clean it up real quick. There we go. And let's look at what we have here. So we've got a whole bunch of stuff. Let's just, for the simplicity of it, let's just look at how much this actually costs. Right, if you've got all of these guys here firing, then we had 8, 9, right? And if we remove all of this, so these are the new generation projectiles.
It's almost imperceptible.
Well, 8, consistently 8, 10 again. Why is it so jumpy? I don't understand why it's so jumpy. I didn't. Oh, I think it's because of the recording. I'm pretty sure it's because of the recording, because I tested this months ago and then it was very stable. But I think it's because of the recording. We could, in theory, just remove the entire on-impact here.
What does that actually do to the visuals of what we're seeing?
Yeah, I'll tell you in a bit.
Yep.
Consistently 10, 9. All right, so tip for the future. Don't do. I think I'm going to do bytecode analysis again for the next sessions because this is too jumpy right now. Even though when I
Well,
do
it's
it,
too yeah, it's too small. I mean, you're down around the lower limits of its measuring ability. So the fact that you're going to have some jump like that, I mean, you're going to see jump in the sim numbers even when nothing is going on.
no, that's true. That's true. Um, but I know in this occasion we can get it as low as 6 or 7
Oh, I
on
don't doubt it.
this
I don't doubt
computer.
it. Yeah.
But let's look at what we have going on here, because there is some interesting stuff going on. Um, let's look at it. Why is it not? Should save it probably. There we go. So we've got this creates the decal, right? So we've got the decal here with a position, which is this fella right here, a rotation, which is this random value, the decal itself, the type of decal, the radius of the decal, LOD, how long it should remain, and the army. And then we've got this really long if statement that checks if we're something that's not a unit or a terrain. Right, so this is right, we're not a shield, okay, we're not water, okay, we're not air, okay, we're not, this runs all of these run the moment we hit terrain. So we should probably say something like this. If the archetype is terrain, then we would like to spawn a decal. There's more going on here. So this was an issue with the original pull request, that there's a 2x damage area here. And the reason for that is quite simple. When we look at tree groups, no. Yeah, there we go. All right, we've got a tree group, and then the first damage instance. So if you would have only one projectile, then the first damage instance would only break the tree group, but it wouldn't cause them to go over. Right, so then you get something like this. So that's why there's 2 force damage areas. The first one breaks the tree group, and the second one actually does the, the tree stuff that you'd expect, where they get knocked over. This was fixed. It was actually not really broken, but it was fixed.
What do you mean by it wasn't really broken, but it was fixed?
Well, I optimized all the props. And what we can do, and that's what we should have done when this was made, because there's some odd stuff happening in here. We reduce the damage, for example, by 2, and that causes issues in other areas. But what we would really want to do here is, first of all, we want the base to happen, right? And the reason we want this is because in the on impact in the base, we go to projectile, go to on impact. This is where already damage is applied in the do damage function, which means that.
So the sequencing.
Say again.
So the sequencing was backwards.
Yeah. So
You want this original damage to take place and then the extra damage. Okay,
yeah,
I understand.
give or take. And this isn't any force damage. This force damage was introduced purely to knock over trees. So what if we just, in our prop tree function, if type is force or type is knock tree, right? Then we try to fall. And here we just say knock tree. And what we can do now, we could, for example, in unit where there's an on damage function too, somewhere, we could add here, if damage type is not knock tree, then we do all of this. So essentially, units are immune to this knock tree type of damage. And this is really beneficial because otherwise the the force damage that we're doing would cause this on damage function to call 3 times on each unit, once with 1 damage,
Yep.
then
And
again
then
with 1 damage, and then with the
yeah,
actual damage.
and then with the actual damage.
So this allows us to simplify some things. For example, we don't have to reduce the damage amount anymore.
Yep.
We don't care about
And you
friendly fire.
and you only end up with 2 damage events.
Exactly, the actual damage and the knock tree damage.
Right. And if a unit is involved, just one single damage.
Yeah, yeah. Well, at least there's one where all the logic is being run, right? Of the do
Yep.
on
Yep.
damage
Exactly.
callbacks, etc.
Right.
We can simplify this one a bit too. We can just vector cached. It's a vector 0, 0, 0. And then here we can say local VC is vector cached. And then here we can say VC1, VC2, VC3 is get position equals that. Do we use the radius? Yes, we use it down there. And then instead of using pos, we use the vector that we cached so that we prevent the table allocation that was going on impact. We've got a radius here. We use that for the damage area of the knock tree. All right. We've got this random float import that we saw before, but we can.
Favorite.
Say again.
I said your favorite last 2
Yes.
weeks.
Yes, yes, yes. Which we can just simplify to random 6.28 times, right? So because we're doing 2 times math.pi.
Yep.
And then we could even just not store this in a local. We could just say that. Then add a friendly comment for our future self. Pum, 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 pum. There we go. The army is not used multiple times, so we can just say self.army. No need to put that in a local. This random float is not used. And we can upvalue this create decal. And this is with the assumption that we want a unit like this to create 5 decals.
Yeah, exactly. Which is, that's a discussion for somebody else, but
Well, no,
the
it's
methodology is sound.
yeah, exactly. Because the only thing that I would imagine that we would want to have here is this knock tree. But even that I wouldn't put in here. I would probably put that in a projectile, saying, well, if we do splash damage, then we do a knock tree as well.
Yep.
Right, and then we could completely remove this entire on impact.
Yeah, but again, going back to the modular class concepts that this thing was obviously designed from, it makes sense that they've used it that way.
Yeah, but this was introduced by us last year in the FAF. So this
tree.
this tree knocking behavior was introduced in FAF.
Wow, that's really obscure.
Well,
I understand the importance of it in FAF. I really do.
I think it's a nice little feature. I just don't think it should have been implemented like this.
Well, it's
where there's all these duplicated code instances.
Yeah, well, sometimes the expediency has more importance than anything else, right? Oh, we have to have this. We must have it now.
Well, then still it would be faster if you just did this. Self dot if
Well,
damage data dot radius is larger than 0, then ends, and then you do a damage area, blah 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 blah, and then you would have had everything too, right?
yes, I know.
So
But it's not unusual. It's not
no,
unusual. You know that as well as I do.
yeah,
It's got a lot of people who've been adding features to this code base for a long time.
yeah, it's something that I will fix in another session, but not for tonight.
Yeah, not for tonight. No.
We've got a no idea, but that's a radius. Then we've got the actual radius. We've got the type. We've got the special texture. we've got the regular texture, orientation, and we've got the position.
Right. And again, this is the LOD only appears when you're zoomed in. I mean, that
Yeah,
100 is fairly low value, and the duration is like, what's that?
10
10 seconds?
seconds. Yeah,
Is
yeah,
that
yeah.
seconds? Yeah.
So that's not really,
No.
I can imagine this to that you want this at the start of the game, in the first 10 minutes, for example, when it doesn't really matter.
Yeah, when it doesn't really matter, but and again, as you're going to see, when you've got 400 of them throwing down decals, it's a lot of load, and
Yeah,
those decals not expiring for 10 seconds means you have all of those events waiting to expire over the next 10 seconds,
yeah,
right?
it's pretty painful.
It can add up for sure. Can add up for sure.
Cast the position, knock over some trees, create a decal if we get. All right, and this is pretty much all we can do here. There's not much more we can do. We upvalue the position. We introduced our own knock tree damage type, right? That allows us to specifically knock over trees. And we did a unit, made sure that the damage type is not knock tree, so that we don't do all this expensive logic here. 3 times every time this unit hits a battleship or something like that. And we make sure that we only create a decal when we hit terrain. Why not when we hit a unit? Because if you have a GC, this fella, if you hit him on the head, you don't want a decal to be created on the ground, which is the current behavior that we have in the game. Another example why we don't want units is if you have a frigate, then the decal is created on the ocean floor, which is again how it's currently implemented. So here we just say if we hit the terrain, then we make the decal. Yeah, that's pretty much it that we can do here. So let's go up the chain. We've got on. Let's first check if the behavior still works. Here we have a bunch of trees. Oof. Oops. Nope, doesn't work. 26. Oops. Unexpected symbol near. What am I doing wrong?
Bracket.
No, I think it's this one.
Right. You don't need to local it.
We don't need to local it.
Because yeah, VC's already declared.
Yeah. So let's try again. Nope.
Now you got worse problems.
More problems. Access to non-existent global pause. Right. So we put that one in here too. Friendly fire doesn't exist either, so let's put on false. Attempt number 2000. Are we gonna fire? Alright. There we go. That's the behavior we expected.
Those poor trees.
Yeah. Let's do it again.
Can't we just set them? Can't we just set them on fire first and then knock them down?
Oh no, but they're on fire first and then knock down. That's the current. Yeah, pretty hefty. All right, but that's pretty much what we can do here, assuming that we want to keep the original behavior. Because if we don't, then what we can do here is this. But that's for another time, another discussion.
Yeah, we're not here to discuss that kind of thing. Just
no,
performance.
Just the performance. So let's go up the chain because there's more that we can do. And when we go up the chain, there's 2 directions that we can take. First one is if we go to default projectiles, then we've got this very large onCreate function that's being called, which is fine, okay. But we can do better here. For example,
so this is invoked when the projectile comes into existence at the barrel.
Yes. So let's look at the chain again real quick. We've got Seraphim projectiles. So here we have the two shells, right? The first
Yep.
one and the split one, and they both inherit from multi-poly trail projectile. And multi-poly trail projectile does, where did you go? All of this logic during the onCreate, right? When the projectile is created, and then the emitter projectile logic, which is all of this. Um, and we've got something to gain here, right? We
For sure.
can do better. So there's two things we can do. First of all, what we could do is we could just do our own onCreate right here. And instead of this inheritance tree that we have, which is multi-poly trail projectile and then emitter projectile and then projectile, we could also just directly inherit from projectile. That's one thing we can do. Projectile doesn't create. So this is one thing. We don't inherit from it, but we do skip the other onCreates in between. That's one approach. The advantage of this is that we know exactly for this projectile what effects we do have and do not have, right? So, for
Right. Instead of
example,
referencing. Yeah.
yeah, for example, if we look at the FX trails, this one has FX trails set, this one does not, which means that for the actual projectile that hits the ground, this for loop that we have here and this function call that we have here is not going to add anything to the effect, right? Because this table is empty the moment because of what we have set here.
Yep.
Another few things that we can look at, we've got the poly trail offset. In both cases, this offset here is empty. But we're still, when we create the projectile, the multi-poly trail projectile, we still offset the emitter by that
Nothing.
offset, even though it's nothing, right? We're not offsetting it actually. So that's a bit meh. And then we've got the fact that this is a global, a get table, a function call, a global, etc. Another global, a get table, etc. So there's a lot of overhead going on here.
Yeah. A lot of the usual up valuing will always gain you something.
Yeah, yeah. And let's first try and just upvalue everything that we have here, because that's never a bad plan. So let's see what we have. We're just going to do it for this projectile here. You would by all means want to do it for all the projectiles, but for this session that's a bit much. So we have a table get m. And like last time, um, the global call is still being done, but now when the file is loaded and not when the file is used continuously. Right, so that's the difference here. Then we've got random poly trails. We've got math4, so local, oops, math4 is math.4. So we've got this one, then we've got this random call here, local random, random, and we've got this create trail, create trail. And then we've got this offset emitter, which is by all means a bit tricky because we don't want to call this when this one is empty. So technically you would want something to do like this, but then we introduce a local, which is expensive too. So this is where we're a bit stuck, I suppose, of removing this one. But this is what we can do here. Then if we go to the emitter one, we've got this. Right. we've got that one going on. That's fine. And here we've got again a skill that's a bit difficult to check on, and we've got an offset emitter that's a bit difficult to check on. So here we're stuck again, kind of. So there's not much we can do in this one.
Well, until you've resolved all the possible values that might come down, yeah.
Yeah, but then we add a lot of logic to prevent logic.
Exactly.
So then we're not really fixing anything.
No.
So this is what we can do if we would directly change these files. Which isn't bad, right? Because this class is used throughout. So all these projectiles are now a tiny, teeny bit faster. So that's not bad.
Nope.
But let's try this approach. Let's see what we have. If we go to the Seraphim projectiles, we know for shell 2 that we do not have trails. So everything that we have in emitter, wrong file, emitter, we don't need to copy this, right? Because we don't have trails. We do have a poly trail, but we don't have an offset. And then we have a bunch of impact effects. So let's look at this. We've got this poly trail. Let's quickly look at what we're dealing with. So we have 2 effects in here. And if we look at how those poly trails are taken care of, if self.random poly trails, is that still 0? Certain projectiles. We're not changing it here, so that's still 0. So we want all the effects from this file. So we can simplify all of this into this value right here. We've got an army. We know there's no offset, right? So we can remove that. And now this would be our, if I'm not mistaken. And we can do this.
Those are for the children, right?
Yeah, these are for the children. We can do the same thing for the not children. And these do have effect trails. So let's look at them again. This one does have an FX trails. Okay, so that means that we need to look at the emitter here too. It's this one. Num poly trails. Self.poly trail. Multi poly trail. Yeah, poly trails. There we go. That means I gotta fix it here too. And group trails. I'm not really sure what the difference is actually between a poly trail and a trail. Oh, wait,
Yeah,
this is the actual. Say again.
Ask the artists.
Yeah, I think I know actually. This is just an effect that looks like a trail, and this is an actual trail entity.
Trail. Yeah.
Create the effects for trails. Create an actual
Trail. Yeah.
trail. And again, we don't scale these and we don't offset them, so we can just remove this. So now we can up value these. Local boop boop boop, and this still fell out. There we go, and we do the same thing for this file right here. We've got a create trail, so we can say something right there. All right. Can we actually not just do this?
Yep, you can. You just get rid of the lookup entirely.
It looks horrible though.
again, how you view it and how other people view it, depends upon how close the reference is. If the reference is like 3 pages up, yeah, you're going to be annoyed,
Yeah.
and you'd have to start changing your visibility all the way through your documents if you want to start doing that.
Yeah. But for this particular case, we can do this.
I'm kind of intrigued about the bringing of all these on create functions up into the projectiles themselves, because do you end up uh, maybe not. I'll wait till we see the effect of it. Are you anticipating a substantial effect from this method?
When I did the testing a few months back, yes.
And that's because you're not iterating up the parent classes or through the other classes to find the on create event. You're just going to do this here.
Yeah, you prevent a lot of function calls, and you prevent a lot. But what matters most
Yep.
is the fact that you don't do this offset emitter in addition, right? We don't do a scale and an offset emitter in addition to
Yeah,
creating the.
I see it. It gives you a finer level of control. You're not relying upon the classing to do all the work for
Yeah,
you.
yeah. And typically, though, I wouldn't do this. For example, for
No.
units, you don't want to do this because mods may hook into intermediate functions. But projectiles, I don't know a single mod that hooks projectiles to do stuff. Right? I
Oh,
don't.
there are some. Trust me, there are some. One that comes to mind right away is like fiery explosions. Total Mayhem does some projectile hooking where it's not creating its own projectiles. Anyway, there are some. Point is,
Okay,
people will find a way to hook the most unlikely things.
true, but um, but they don't hook it to change the Zuti projectile.
Well, you never know, right?
I don't expect anyway. But you're right. Typically, you don't want to take this approach. But for projectiles, I think it's okay to skip a beat.
Well, I do too, especially for base class things,
Yeah,
because that's 85%. Even if you have a lot of mods in your game, 85% of the work you do or that
is
your game will do is going to be on base class units and projectiles.
yeah. And in this case, the number of projectiles is really high, right? Because we multiply it times 5
Oh,
by
absolutely. But
the
this
creation.
this applies to any of those projectiles, like torpedoes. Torpedoes are perhaps the worst because they generate an absolutely huge list of effects. They have
No,
all
really.
kinds of oh yeah, all kinds of trails and bubbles and steam and
Oh
all
yeah, you're
kinds of
right.
things going on. And the unfortunate part about it all is that it's all underwater.
Yeah, so you
So
don't get to see it.
you don't really get to see it, but you drop 20 torpedoes into the water and you've just spawned 120 effects.
Yeah, yeah. No, you're right. But there's more we can do. We're not done yet.
No, of course not. We're never done.
We're never done.
No,
So,
we're never done.
what can we do more? Well, um, one thing we can do is this on create is still called. So we can
This
optimize this on create. This is the on create of the base projectile.
okay.
So we can optimize some stuff here. We could, for example, that value for performance, right? Because we're going through the entire chain. We've got this local entity get army is model entity methods get army. We can get rid of that one. We've got the trash bag here that we're making. So local trash is trash bag, which is a global, right? That's the trash bag we have right here. We've got this set max health, set max health. We've got the set health itself. Set health. And then change the other side here too. We've got another interesting thing happening here. So let's just say this is all of this or one. And then we can just do that. And here we add self entity. There we go. Then we've got some audio loop. This one's pretty tricky. Only used by strategic missiles. No other projectile in the game has this value set. And this is
Great,
only
great.
yeah, only used by tactical missiles. So technically we could remove this one too. But more importantly, there's this and. So this value has to exist and it has to be set to true. I think this is just fine. But this doesn't get run, this inner part for what we're doing. So set some health. Now there's one tiny thing that I need to fix because I broke that last time. I broke the caching functionality we have. Wait, no, I didn't yet, I think. No, not yet. Never mind. Okay, so we cache our blueprint. We've got the cache, we got the blueprints, we've got some empty damage data that we populate. We could even go further. We could say, well, this damage data doesn't exist technically. It starts existing when we call the pass damage data function, right? So
Yep, doesn't exist until then.
yeah, and here it gets populated immediately, so that's fine. We could even optimize this to function better,
inside of it. Yep.
but we don't have to for this particular case because we're just assigning the damage data here. We're not passing it along. So we're skipping this function
Yep.
altogether, so we can do that. Then this is the onCreate. And the other one that's gonna get called quite often is the onImpact. And this one's a bit more tricky. So let's carefully look at it. We've got this get launcher here. So we can do local projectile get launcher is g.project moho.projectile methods.get launcher. Right, so we've got this little fella. Got the damage data, we do some damage. We do unit impact buffs, but we only do that when we actually have buffs. Now this is interesting what's happening here. So let's actually just run this real quick and see what our data.buffs value is. Because this is actually assuming that our projectile doesn't crash. It crashed, of course. For limit must be a number. What am I doing different from here? Comparison to here.
Self polytrails must not be a number. Maybe it's false or nil.
I thought we just confirmed that it wasn't. Aha, we've got more errors. Projectile. Apparently we don't have. Alright, so now we gotta restart. Maybe this is no value in this case. Let's go to Zuti. But it's the same type of access to self.polytrails. I don't understand. Why is this one working? And with regards to the syntax, it crashes at 45. So it crashes with this one, but we do the same thing here. They're both tables.
Go ahead, look carefully at it for a second. For I in stealth effects trails. For I
Nice. Nice,
yeah.
nice, nice, nice. Okay. I actually wasn't aware of this syntax until I looked at
Neither
this.
was I. I was not aware of it until you just did it there.
Yeah. So, okay, one
The
problem.
question is, what is it really executing?
I think it's doing a table get hen internally. That's what I
Oh,
think.
oh,
All right.
that would be useful.
But what we have here, and that's what the interesting part is that I wanted to show you, with this do unit impact buffs,
Yes,
it checks if the data debuffs is a true v value,
but it's
and
already made data.
yeah, exactly, it's an empty table right here,
Yeah,
which means that this is always going to pass. The for loop is always going to try and execute once, and then it fails, and then nothing happens. So what we want to have is not an empty table or something like that, or for example, table.getEmpty.
yeah. Table dot empty.
So table empty. So we want to have this check here actually.
And make it if not.
If not table.empty. So now we skip this for loop here, at least once. So that's nice. Then we go back to here. We've got some impact effects. So this is interesting. We set the impact effects to an empty table, and then we check if we have an impact effect, which means that we're probably going to throw this empty table away. So let's set this to false. And we can just say, well, local of impact effect is impact effect or an empty table. So that if we did set the value somewhere here, then we didn't throw away that empty table. But if we didn't set it somewhere here, then at least we have an empty table. But note that this is never going to be true in practice unless we have a mod, because if we look at, for example, the styrofoam projectiles, if we don't want an impact to happen, then the default is to set it to an empty table. Which means that even if the, between quotation marks, impact effect doesn't exist, this is going to give us an empty table back.
Every time.
Every time. So this OR statement is probably never going to hit unless there's a mod that's trying to do something funky. And that happens. So
That's a shame because it implies that we create a lot of empty tables. Or
yes.
potentially, yeah.
Yeah. But I'm not really sure in practice if that matters. I
Well,
have to test that. Let's test that real quick.
but just on the principles that we're working from, we have to assume that we're creating an empty table even if it doesn't get used. The garbage collector's still got to pick it up shortly thereafter.
Yeah. Yeah. But I'm wondering, okay, so it does create unique tables, right?
Okay, all right.
So every empty table that we make is a unique one. So doing this prevents us from creating that one empty table. I'm not really sure how much memory it would really save, but
If
you know,
any, if any,
if
yeah,
any.
if any. I agree. If any, it's just
Yeah.
for the principle of what we're doing, in terms of trying
Yeah.
to minimize the number of empty table creations, because that seems to be an important facet of the whole project. Is the more empty tables we can do away with, the better.
Yeah. Then we've got this self get blueprint. Well, we already cached that once, so there we go. We cache that here and on create, right? The blueprint. We play some sound. That's fine. We do this entire check. One could argue that one is very likely to either hit terrain, then water, and then a unit. So let's switch this if statement up slightly. So I'm gonna do this right. So if it's terrain, else if it's water, and then I'd say that hitting unit a unit air, I'm not really sure what that is. Impact air unit, okay, that makes sense. Projectile, we're probably, our shield is probably quite likely too. Right? Which means that if we had a shield, it would need to go over all these if statements before we would actually get to the shield.
Yeah.
We can't hit props. They don't have collision boxes in terms of ones that projectiles can collide with. So this one's probably never going to happen. We've got projectiles. This would be used by TMD, which, yeah, I think that's more likely than we hit something in the water. So that doesn't really happen that much in practice. Should definitely not be at the top. FX impact lens scorch. I recall we set that somewhere, which is FX impact lens scorch. It is set to false here, and then it's never used. At
Excellent.
Yeah. I think we can just do that. Honestly, I think this was the original implementation of having decals on the ground for projectiles.
Probably.
Right? Because that's what
you see a lot of it, right? This exact type of method is all over the place.
Yeah. So we can, I think we can just get rid of all of this together. Because we, in FAF, we have our own version, which is this one right here. All right, so this is good. We've got a log. Doesn't really matter, never hits. Gets rain effects. So this one is interesting too. Let's see what we have. First of all, we do a get position, which doesn't sound too bad if we didn't already do that. For example, in do damage. Here we do a get position too, which means that we're getting the position twice, and that's a unique table each time. So one could argue that I think you could do this.
Is this the position of the projectile?
Yeah. Yes. So, and what we're doing here is we need to get the position of the projectile to determine the terrain type, and then to determine an impact effect. So that's why we're doing a get position here again. So we can cache that position. So let's do that. We can say, well, you know, cache information for performance or localize. What we can say is we create a local vector cached. It's a vector 000, and global PC is vector cached. VZ1, VZ2, VZ3 is self get position,
YZ,
which is again something that we can up value. So we go entity, and then local entity is underscore g g.moho.entity methods dot, right? So now without this bit. And then we can say, well, we just give the position here. And for mod compatibility, we can say position. A position is a position or self position.
forget your comma.
Yes. And then here we can switch out all of these, which looks like it happens a lot, but that's actually not the case because only one of these hit because of all the if statements, right? So only one get position would get called at some point, because this runs or that runs or that runs or that runs. It's not all running at once. But this allows us to get rid of that position. Call in this function. And then we can go further as we have this get terrain effects where we can add the position to. And then we go back to the get terrain effects where we have a position. I'm not really expecting this to be called by a mod, but for the sake of it, we would say, well, position is position or self get position. All right, and here is something interesting. We've got get terrain type. By all means, we can cache that, right? That's a global call. We're not really a fan of those, so local get terrain type is get terrain type. That's now enough value. But there's one that is very often used, and that is this one right here.
Right there, yeah.
So we can say local default terrain type is that.
Is this?
And then we can say, well, okay, if this is the case, then we don't have to call this function again or at all. Terrain type dot fx impact target type, which is an argument. Impact effect type, which is an argument, or an empty table. Nice. Or false. So we try and return this, or it's false. And we've got the default terrain type going here. So that's good. So then here we've got a bunch of terrain effects. If we have terrain effects, terrain effects. So, right, so I bought a new keyboard for my desktop so that I don't have the mechanic keyboard that I was using last time, because that really messed with the recording. But now I gotta get used to the keyboard. So this is the terrain effects. These are the impact effects. Create impact effects. I'll do that one. Boink. Boink. Effect table. Effect scale. Create emitter at bone. We can cache that. Create emitter at entity. We can cache that. And then we scale the emitter if we have an emitter, which doesn't make sense because we'll always have an emitter in this case. So we can check, we can remove this check. But if the effect scale is not 1, well, that seems fair enough, right? We don't want to call this necessarily. That seems fair enough to me. So let's get back. We did the terrain effects. And then here we have some kind of timeout value. I have no idea when this gets used, but some timeout value have fun. And then we have on. So if we don't have this, if we don't have a timeout, then we do this on impact destroy. And I have no idea what this is trying to do. So let's look at it.
Where's the projectile?
Well, that's self, I think. So self.
Yep.
So if we destroy on impact, then we destroy ourselves. Right. So.
Which is kind of self-explanatory, but they don't do a very good job of that here.
Yeah. Let's see. Not all projectiles do that, apparently.
No. There are some projectiles that are in fact designed to pass through units and come out the other side and carry on and impact other things.
The decoy flare projectile. Surface targets. Apparently these go through units as well. Okay. So this can happen. So if we're not doing that, or there's no target entity. What is target entity? That is what we've been given. That's probably the thing that we hit. Or not. All right, so if this didn't pass, then this is implicitly true. Right? If this is not true, then it must be false. So we can remove that. Target entity. If this didn't pass, then this has to be true. Right? So that's inherently true. Entity category contains. Oh, so we don't want anti-missiles.
What the hell is that?
I have no idea.
Either do I.
But we can cache these categories. Check. On impact categories. We can do that. Destroy categories. That prevents these computations. And we can cache this one. I have no idea. Okay, so if we destroy an impact, then we destroy ourselves. If we don't have a target entity, that means we hit the terrain. Then we destroy ourselves. But if we don't destroy an impact and we do have a target entity, then we should not destroy ourselves if we're one of these categories.
Oh, I gotta wait to see how that works out.
I'm
It's tricky.
I'm still a bit
It's tricky.
I'm still a bit flabbergasted what this actually says.
Yes, as am I.
If there is no target entity, so if we hit the terrain, then we destroy. Well, that makes sense, right? If we hit the terrain, we destroy ourselves. If we destroy an impact, we destroy ourselves. Or if we are not an anti-missile times all projectiles. All right. But that's the on impact destroy. That's right there. I think this has to do with strategical missiles. But why is this in?
I have a sneaking suspicion it's designed to make them stop, not impact on shields.
No, there's a separate check for that with the shields. There's an
Why wouldn't strategic missiles impact shields? I've always asked that question.
well, there is this mod where they do.
Yeah, there's a mod where we do that all the time. It's called Loud.
Oh yes, well, but do they impact their own shields?
No.
Well, there's a mod that does that, and that's hilarious because then you forgot to turn off the shield that is, protecting your launcher, and then you blow
that's
up
right.
yourself.
It hit the inside of the shield, did it?
Yeah. That's beautiful. There was something in FAF about making a base essentially impenetrable when you have sufficient shields.
Oh god.
Entity destroy is g.minho.entity.destroy. But as this is called pretty often, let's just get rid of that one. Oops. And then we've got all the on impact stuff done. There's not much more we can do here to make things better. I think one could get this check into the outer, but that's not going to be a massive difference. Do we still work? Didn't crash right away, so that's nice.
Oh, there you go.
All right. Position 417. 417. This is called PC. Restart. All right. Duty.
Come on, kill those trees.
I already did. Look. Oh. Pulse. 316. Position. Pulse of X, pulse of Y. Alright. So let's try this again. This is why I added a peak hole at the start.
It's interesting to see you come up against the terrain effects because there's very few.
Mm-hmm. I know.
It's one of those unfinished systems.
Yeah, I think so too. Attempt number 3. That seems decent to me.
Oh, look at those pretty little decals, aren't they?
Yeah, they're cute. Okay, so now let's make 400 of these. And move them into position and do a run with the wind. To into position faster, and then we can do this. Quickly zoom out. Wind. All right, make you stop. Eight, 9, 10, 9, 10, 8, 9, 8, 9 again, 7. Oh,
Yeah, there's a 7 for the first time.
7 for the first time. Now it's back up to 11. All right.
Well, again, like you're down near the noise floor, so I'm not
Yeah,
surprised that you're getting these erratic numbers.
yeah. But I think these numbers go up and down because of the stream.
Oh, yeah, I think
I
they
think
do, and
that's
they go up and down with everything else your computer's probably doing too.
yeah.
So
Let's check the baseline real quick. At a baseline, when we don't have any projectiles, we have 3.5, 3.3, 2.9. Okay. So let's try this again. 8, 9, 8. Well, considering that we started with 10, 11 and
yeah,
not going lower than that. So if we run the numbers, right, the baseline is say 3 to 4 ms when optimized. 8 to 9 ms. Is that safe to say, or is that a bit too enthusiastic?
8 to 10. The
8 to
point is you
10.
come out ahead. You come out ahead.
Yeah. But then what matters is the difference, right? So here we have 7 difference before, 7 to 8 difference after, 5 to 6. Wait, no. 8, 5, 10 minus 4, 6. Yeah. Roughly, say 20%, 30% performance increase. Smiley face. Because that's the difference is what we're measuring here, of course. Because of the baseline of the entities just existing. All right, I'm gonna run this again when I'm not streaming on Discord and recording.
Yeah, get some different numbers.
Get some actual numbers because this is going up and
Now,
down.
yeah, some of the work that you did here today applies to the baseline projectiles class. So
Yeah,
you're gonna have impact across
all the
everything.
projectiles.
Yeah.
Which means that it needs very thorough testing too. it's going to
Yeah. Well,
impact
that's
all the
well, that's exactly. Yeah, and that's exactly how I would do my testing too.
Yeah,
I would have had a baseline simulation run without any of the any of the
other
changes
stuff.
whatsoever. Yeah, and then I would run the same I would run that replay back before making any changes and then run it after
Yeah,
making changes. None of these changes should have caused a desync situation. So
no. Well, yes, there is one where we changed the knock tree force damage. And you can do
okay,
this too,
all
by
right,
the way.
that's true.
You can change these init functions to false instead of them being a function. And the reason for that is if we look at the class table thing, it
Never uses them.
checks if the function exists and then it calls them. But the reason that we define these functions here is to prevent the entity functions to be called, right? We don't want the entity version of underscore init. But if we define this with an empty function, then by all means,
We'll try and run it.
it will try and run it because this is a true value, and then it runs it during the unpack and the function call. Whereas if you just set to false, then that check right here will fail and then it doesn't run at all. Minor change, but considering projectiles get created a lot, doesn't harm.
No,
It works for you.
I never picked up on that one.
Yeah, works for units too.
Yeah, I can't think of any class that I've ever seen define an init or a post init.
Only
Is there
entity
one? Yeah,
that uses it to create the C side of the entity.
yeah, but that's the end of it, and then it also initiates the on create.
Yeah, but that's not the case actually,
No, what
because
on create is that running?
well, if we look at unit.lua, then that one
Yeah.
has this one doesn't inherit from an entity, but its on create is still running. Oh wait, we're doing it. Yeah. So this on
Okay.
create is calling the entity on create. Why is it doing that actually? Because it's not inheriting from it.
If I had $1 for every time I asked myself that question,
Right.
you and I could be having this discussion face to face in Hawaii.
That sounds good. I
It
like that.
does.
But that's it for today. So this last one got pretty big. Git stage, git commit, optimize Zuti projectiles.
Amongst other things.
Amongst other projectile things. Git push, set stream, origin, optimize projectile sample. And now this type of optimizations could be applied to a lot of other projectiles too.
Oh gosh, yes. That's why I asked about
So
the method of moving some of those on creates up into the projectiles themselves, whether that's, something that could be more globally applied.
I think for projectiles you can safely do this, yes.
Yeah, I agree.
I would not,
Especially, like I said,
yeah,
base projectiles.
yeah, I would not do it anywhere else. But I think in particular in this case, this is interesting because the Zuti is a unit that's very often on the map, right? There's a lot of
Yes.
Zutis practically, and um, in particular in this case, it creates 5 additional projectiles,
Yes.
which is something that always sounds bad.
Yeah, those splitting projectiles are nasty beasts.
Yeah. All right. That's gonna be the recording. So let's turn that